here's example 2 of lesson 20F. What we're going to do in this example is we're going to find the equation of the normal. Remember, normal is your perpendicular line to your tangent line. So example 2, we want to find the equation of the normal to the curve. So this is our function. It's a quadratic function. And the point at which we are going to create that tangent line and the normal line is at x equals 4. So step 1, we want to find the y coordinate by substituting the x value, which is 4, into the original function. And what we're going to get is your point of contact. Where does that tangent line and normal curve touch? So here we go. We're going to go ahead and evaluate the original function for 4. So f of 4 equals, replace the x with 4, replace the x with 4. And then we simplify it. 4 squared is 16. Negative 4 times 4 is negative 16, and then add 3. Well, the positive 16 and negative 16 become 0, and then we have 3. So f of 4 is 3. This is your point of contact at 4, 3. So to help us out, here is your quadratic equation graphed out. That's your function. And then there is a point of contact right here at 4, 3. That's going to create a tangent line in a little bit. All right. So step 2 is to find that equation of the tangent by first finding the gradient, which is your slope. So how you do that, we've done that already earlier in our unit, is by first finding the derivative function using our power rule. And then after that, we're going to substitute the x value into the derivative function to find the gradient. All right, so let's go ahead. That original function, again, was a quadratic. So I'm just going to write your quadratic equation down. And now we're going to find the derivative function using our power rule. So there's our derivative function. Now we're going to go ahead and substitute the x value, which remember that x value was 4. So we're going to evaluate that derivative function at 4 and then simplify it. So we get 4. What did we just find? That is the slope of your tangent line, the gradient of your tangent line. Now, step 3. To find the gradient of your normal, that's your perpendicular, you're going to take the negative reciprocal of that slope. So if this is your slope in step 2, which was 4, to find its normal or perpendicular line, m sub 2, you're going to reciprocate that, 1/4, and then change the sign to a negative. So that is the gradient or slope of the perpendicular line, or your normal, at that point 4, 3. All right, step 4, we're going to substitute the normal gradient, the x value, and the y value into our y equals mx plus b. And we're going to solve for b, which will be your y-intercept. So remember, our y value was 3. Our slope of our gradient is negative 1/4. Our x value was 4, and then our b is unknown. Our b is our y-intercept. So we're going to solve for b. Well, these 4's are going to cancel out. So we're going to be having 3 equals negative 1 plus b. We're going to add 1 to both sides. So our b value is 4. So the equation for our tangent line is y equals, you substitute your slope in, negative 1/4. Substitute your y-intercept, which you found up there, and that's the equation. So here is your quadratic, your curve, your function. Here is your normal line. That's perpendicular. So imagine this would be your tangent line here, which we didn't find that equation. That would be where the tangent would be. But we found the red function.